In this video, I'm going to go through two past paper questions that look specifically at the Hicksian substitution effect, but also how do we explain optimal bundles using this condition. So what does it mean if we are at a consumption point where the marginal utility ratio does not equal the price ratio? And then I'm going to do one graph showing you how to draw out the Hicksian substitution effect and the income effect. So I'm actually going to start here because I've combined these two past paper questions into one because they actually relate to each other. And this starts with some of the more basic theory that comes from chapter 3, whereas this question from the 2023 paper goes more into chapter 4, so looking at the substitution and income effect. So we get given this graph, and we're told that given the above graph with budget constraint B dash B dash, so that represents this line here that runs from B dash to B dash, where the consumer consumes food and shelter, so food is on the y-axis and shelter is on the x-axis, explain why point C, which is this point over here, is not an optimum. So it's not an optimum point for the consumer. What must the consumer do to maximize his or her utility? Explain your answer in detail. In the next question, we have similar sort of thinking, but here it says, suppose the consumer that consumes clothes and food operates where the marginal utility of food divided by the marginal utility of clothing exceeds the price of food over the price of clothing. Is the consumer in equilibrium? If not, how can they adjust to equilibrium? Explain your answer in detail. So these two questions are asking us actually to do two identical things. The one is just asking you to interpret a picture, whereas the other one is asking you to interpret the tangency condition, but using this inequality, relating the marginal utilities as a ratio and the prices as a ratio. So I'll start with this one. So if we look at point C here, what we would say is that the slope of the budget constraints at point C is represented by the steepness of that green section of line. Okay, now obviously the slope of the budget constraints is the same no matter where you are on the budget constraints because it is a straight line. But I'm just drawing this section here so that I can contrast it with the slope of the indifference curve at that point. So if I had to draw a tangency to this indifference curve at the point C, I would say that the slope of that line represents the slope of the indifference curve. So the slope of any budget constraints is equal to minus the price of the product on the x-axis, which in this case is shelter, over the price of the product on the y-axis, which in this case is food. So I say it's negative because it's a downward sloping line. Usually when we interpret the slope of the budget constraint, we interpret the absolute size of this value because we know that it is going to be negative in any case because it represents an opportunity cost. It represents how much food do I have to give up every time I buy a unit of shelter. So that's the slope of the budget constraint. The slope of an indifference curve is the marginal rate of substitution. And we can also represent the slope of the indifference curve, this marginal rate of substitution, as the marginal utility of the product on the x-axis over the marginal utility of the product on the y-axis. So the slope of the budget constraint is the relative price of shelter, and the slope of an indifference curve is the relative benefit of shelter in terms of food. So what we're doing when we compare the two slopes at this point is we want to see, is it true that the marginal utility from shelter over the marginal utility from food is equal to the price of shelter over the price of food? So is this the case? And what we know is that if these two values are indeed equal, then we are